Okay, I asked you to learn 10 through 13 on the math workshop today. So let's start with number 10. I'm trying to think of two things that multiply to give me 54. I would love for one of those numbers to be a perfect square. So maybe 9 times 6. And then, hey, I know the square root of 9, that's 3. So it ends up being 3 square root of 6. But again, we still haven't talked about the variable. So it was an even exponent, p to the 8th. So 8 divided by 2 is 4, so it ends up being 3p to the 4th square root of 6. Okay, on the next problem, square root of 16 is already a perfect square. Hey, I know the square root of 16, that's 4. Now to deal with that exponent, t to the 11th, oh, that's an odd one. So I back down to 10, and I say, it ends up being t to the 5th, because 5 times 2 is 10, and there's 1 left under the house. Again, if you need to, worst comes to worst, make out a list of 11 t's, 3, 4, 7, 8, 9, 10, 11, and do some circle buddies. Pairs get to go. So I've got 1 pair, 2 pairs, 3 pairs, 4 pairs, 5 pairs get to leave the house. That's why it's t to the 5th. If that last t doesn't have a match, he gets to stay home. So at worst, you can do that. 72 is 9 times 8. I know the square root of 9, that's 3. Oh, but I've not picked a big enough one because 8 reduces 2. So 9 times 8 is great, but there's got to be a bigger perfect number that goes into 72 than 9. So let's see, I bet it's 36. And I would be right. I should instead do 36 times 2. I know the square root of 36. It's 6. So I have 6 square roots of 2. But I still haven't dealt with those variables. J to the 2nd, 2 divided by 2 is 1, so a j gets to come out. K to the 15th, that's an odd exponent, which stinks. So I think, let's see, I back up to 14. 14 divided by 2 is 7, so K to the 7th. 7 times 2 is 14. And I have 1 K left over. So it should be 6JK to the 7th, square root of 2K. I don't feel like you can read that well, so let me write it again. 6JK to the 7th, square root of 2K. Okay. Woo. As for number 12, 200. Oh, that's easy. It's 100 times 2. I know the square root of 100. It's 10. So 10 square roots of 2. I've got to go back and deal with those exponents. W to the 10th. Well, W to the 10th, 10 divided by 2 is 5. So I have W to the 5th. X to the 3rd. If I back up to x squared, it goes in 1 time. I have an x left over. And then y to the 4th, 4 divided by 2 is 2, so y squared. So your answer should be 10 w to the 5th x y squared, square root of 2x. And again, I know we're right because the only time you should end up with a variable underneath the radical is if it had an odd exponent. X to the 3rd, that's our only odd exponent in this problem. Okay, I also asked you to try number 13. It says, determine whether the following statement is sometimes, always, or never true. Explain your reasoning. I always hate these. Sometimes, always, never freaks me out. Oh well. An irrational number is a real number within a radical sign. So I'm not really sure. So let's make a list of some real numbers we know. 1, 2, 3, 4. That's a couple of real numbers we know. Within a radical sign, so let's add a house to each of these numbers. Square root of, square root of, square root of, square root of. Okay, well, square root of 2, second square root 2. If you type that in your calculator, you do end up getting a non-repeating decimal. And it does keep going. My calculator stopped, but it keeps on going. So technically that is an irrational number. So it's true with the square root of 2. And then I could do the same thing with square root of 3. Second square root 3. Also getting a non-repeating decimal. I know it looks like it is repeating, but I swear it's not. Again, my calculator is rounding for me. Bless its heart. So square root of 3 is also irrational. But square root of 1 is not irrational. I know that number. Square root of 1 is 1. Square root of 4 is 2. So it's not true if we have a perfect square like 1, 4, 9, 16, 25. So it just depends on what kind of number we have. Are they a perfect square or not? So I'm going to go with sometimes. Okay, you need to have out your notes. We're on page 2 of our new matrices packet. We were talking about matrices yesterday and how to determine their dimensions and how to solve equations with x, y, and z involved in a matrix. Today we're going to add and subtract with matrices. First things first, you should probably read the directions, always helps. It says, perform the indicated operation. If the matrix does not exist, write impossible. Okay, when the matrix does not exist, so we can't do it. So when are we not going to be able to do addition or subtraction? Well, I guess that's why we talked about dimensions yesterday. You need to compare dimensions first. If your two matrices do not have the same dimensions, they're not both 2 by 2s or 3 by 3s or so forth, then you're not actually going to be able to add or subtract with them. Okay, so I'm looking at number 1. I see it's 2 rows, 3 columns. The first matrix is a 2 by 3. The second matrix, 2 rows, 3 columns. It's also a 2 by 3, so I'm going to be able to add or subtract with it. It's an addition sign in between, so I'm literally going to add across to my like terms. So I am going to add 6 plus a negative 4, and I am going to get 2. And I'll do negative 5 with 3. Negative 5 plus 3 is negative 2. I'm going to add 9 plus 2, get 11. Negative 3 plus 6, well, that ends up being a positive 3. Negative 4 plus 9, 9 minus 4 is 5. 5 plus a negative 4, that ends up being 1. Wow. Okay, and then let's skip around. Let's go to number 3 because it's another addition one. Let's handle all the addition ones first. So number 3 again, I see it's a plus sign in between the two matrices. I consider, are the matrices the same dimensions? 2 rows, 2 columns, 2 rows, 2 columns. So yes, they are the same dimensions. And then after that, okay, sorry, I got distracted. Can you believe people still need me after school? Crazy. Okay, number 3, we want to again add matrices. So I'm going to add 16 plus negative 4, I get 12. 2 plus negative 1, I get 1. Negative 9 plus negative 3, I get negative 12. 8 plus negative 7, I get positive 1. So adding with matrices is super easy. Multiplying. Oh, we're not doing that today. Subtraction is going to be just as fun. So let's go back to number 2. Again, I think about my dimensions. Can I do this problem first? 2 rows, 2 columns, it's 2 by 2. 2 by 2 as well, so we are able to complete this problem. So I'm actually going to write this one out, but you don't have to if you understand. So we're going to do 8 minus negative 4 for that first entry. So I in my head understand 8 minus negative 4 ends up being 8 plus 4, which is 12. So if you want to skip straight to the end, you can. No one's mad. If you need to write it out, you can as well. So my next entry, I'm doing 7 minus 3, which is 4. For my next entry, I'm doing negative 10 minus 2, which is negative 12. And for my last entry, I'm doing -6 minus -12. So it ends up being 12 minus 6, which is just +6. Okay, so if you want to write it out like I did in number 2, that's great. But I tend to just do these in my head, and it's great with me if you're doing these in your head as well. It doesn't matter. Okay, number 4, another subtraction sign. And I'm just like you. I immediately was like, oh, okay, 8 minus 5 is 3. -2 minus 10 is -12. But then I got stuck, because I was like, but this one has 3 rows, and this one has 2. This is a 3 by 2. This is a 2 rows, 4 columns, 2 by 4. They're not the same dimension, so we're not able to work this problem. So it's not possible. The matrix C does not exist, so we're going to write the word impossible. Okay, now let's go to number 5. I can already tell this one's going to be a good one because I see it's a 3 by 3 and a 3 by 3, so I know we can do the math. I'm going to try to do this one in my head. 5 minus a -8. That ends up being 5 plus 8, which is 13. 0 minus 7 ends up being -7. -3 minus -2. Well, that's -3 minus a negative, so -3 plus 2, which is -1. Now for my second row, -6 minus 5, I get -11. 9 minus -9, well, that ends up being 9 plus 9, which is 0. 7 minus 3, I get 4. Now as for my last row, 2 minus -3, well, that ends up being 2 plus 3, which is 5. -4 minus 4, I get -8. -4 minus -10, well, the minus a negative, that ends up being a positive, so -4 plus 10 ends up being +6. So again, adding, subtracting, no big deal. And now we are going to multiply by a number. We're not going to multiply 2 matrices together. We're just going to, it's called a scalar when it's out there like that. We're just going to multiply every single entry by that -4. So really, it's like we're distributing. We're going to distribute that -4 to every single element in this matrix. So I'm going to do, and if you need to write it out, you can, -4 times -12. I'm going to do -4 times -6. -4 times 6. -4 times -13. -4 times 15. -4 times -9. -4 times 4, and -4 times 8. But again, really all I'm just doing is distributing that -4 to every single element of that matrix. So if I wanted to jump to the answer, I could have to begin with. -4 times -12 ends up being +48. -4 times +6 ends up being -24. -4 times 15, we get -60. -4 times 4, -16. -4 times -6, we get +24. -4 times -13, we get +52. -4 times -9, we get +36. -4 times 8, we get -32. And that's all we're really going to do with adding and subtracting and then multiplying by a number on the outside called a scalar. But of course, as always in life, we can make things more complicated. So look down at the bottom. We figure out how to make things more complicated. As we discussed yesterday, if you're going to represent a matrix using a variable, we always use uppercase variables to represent matrices. So A plus B really means add matrix A plus matrix B. So I'm going to add A. A is 0, -7, 8, 12, plus B, which is 11, 4, -3, -17. When I add them together, 0 plus 11, I get 11. -7 plus 4, I get -3. 8 minus 3, I get 5. 12 minus 17, I get negative 5. Now, if you knew that answer without actually writing down the two matrices, because you can add it up in your head above, that's fine. No one is mad about that. That's terrific. Okay, number 8 wants to do 4 times C. Well, matrix C is 8, 2, negative 2, 1, negative 9, 15. So I'm going to multiply every element of that matrix times 4. So 4 times 8 is 32. 4 times 2 is 8. 4 times negative 2 is negative 8. 4 times 1 is 4. 4 times negative 9 is negative 36. 4 times 15 is 60. Woohoo! And now we've got 9 and 10 to deal with. Whew, it looks a little more complicated. Let's see, 9 is 7 times A. Matrix A is 0, negative 7, 8, 12. Minus 2 times B. So I really get to do 2 things this time. That's exciting, or maybe even 3. So 7 times each of these elements. So I get 0, 56, negative 49, 84. And then, so we've got some options with this. We can leave the minus and just distribute the 2. Or you can distribute the negative 2. I'm going to leave the minus and just distribute the 2. 2 times 11 is 22. 2 times negative 3 is negative 6. 2 times 4 is 8. 2 times negative 17 is negative 34. But we're not done. We still have 2 matrices on the screen. We would really like to have only 1. 0 minus 22 is negative 22. Negative 49 minus 8 is negative 57. 56 minus negative 6 ends up being 56 plus 6, which is just 50. 84 minus a negative 34 ends up being 84 plus 34, which is 118. So we're done with number 9. And I'm out of room to put 10 up there, so I'm going to have to do 10 down here at the bottom. Okay, so number 10 is supposed to be 5D plus C. Well, D is negative 2, negative 8, 0, 4, 13, 1, plus C. C is 8, 2, negative 2, 1, negative 9, 15. So 5 times D is going to be negative 10, negative 40, 0, 20, 65, 5, plus, and this one didn't get multiplied by anybody, so I'm just going to write them down again. 8, 2, negative 2, 1, negative 9, 15. Sorry, I'm having to turn this in at the bottom. Again, since he wasn't multiplied by anybody, I just wrote him down again at the bottom near this guy. Okay, there's a plus sign in between, and they are the same dimensions, so I can't add them. Negative 10 plus 8 is negative 2. Negative 40 plus 2 is negative 38. 0 plus a negative 2 is negative 2. 20 plus 1 is 21. 65 minus 9 is 56. And then 5 plus 15 is 20. So that's our final answer. So again, it's really no big deal. It's just we've allowed these capital letters to represent matrices, and now we have to actually plug in and do math with the matrices. Okay, I hope everything's good. You need to work on this worksheet now. It's okay with me if you skip 19 and 20. But, I mean, my goodness, please be brave, especially if you've got most of this done already. It's just going to require substitution. That's where you can handle it. If somehow you finish all the things, good for you. There is a checkpoint. Wouldn't it be awesome to go ahead and get it out of the way? Okay. Have a great day, guys.